Hello student, this is the fourth part of permutations and combinations. That too, our first part is about permutations, that too linear permutations. So we derived a formula for NPR. Meaning of NPR means from n distinct objects selecting R and arranging R in a row is NPR. The value of NPR is n factorial by n minus R factorial, or NPR is nothing but n into n minus 1 into n minus 2 into so on, n minus R plus 1. Okay. So our mathematical actually if R equal to n, so what happened, NP n becomes n factorial. That is one thing. If R equal to 0, this actually never happens. You can't select 0 from n, you can't arrange. But mathematical convenience, NP0 treated as 1. Okay. So how I will prove? Put R equal to 0 in number formula. NP0 equal to n factorial by n minus 0 factor, that is n factorial, that is equal to 1. Just for mathematical convenience, NP0 is treated as 1. Okay, this is the yesterday's concept at a previous part concept. Now today I am going to explain some problems based on NPR. Okay, here we have the first problem. Find the number of 3-digit numbers that can be formed by using the digits 2, 4, 7, 8, 9, and among how many of them are divisible by 2 and divisible by 4. Three problems are there. How many 3-digit numbers? Among 3, how many are divisible by 2 and how many are divisible by 4. Students, listen now. Solution. First of all, I find number of 3-digit numbers. Number of 3-digit numbers. Yeah, number of 3-digit numbers. 3-digited box. We have just I want to write the box. Just the digits 2, 4, 7, 8, 9 should be filled into 3 blanks. By using permutations, I can say that here 5p3 ways I can fill. Directly I can say the 5p3. The answer is 5p3. Means there are 5p3 3-digited numbers. So you want to find a numerical value. 5 into 4 into 3 only. That is 60. So 60 3-digit numbers you can write. For among the 60, we want to find how many of them are divisible by 2. So divisible by 2, among the 60, few numbers like this: 247, 472, okay, 478, like that. So this is not divisible by 2, but this is divisible by 2. This number is divisible by 2. What the divisivity rule saying that unit digit of the number should divisible by 2. Means among the 60, now we want to identify how many numbers are there. They are end with an even number. So how to identify? How to find logically? That I will write here. The number of three-digit even numbers I can write. Students, listen. How to find logically? That is important. We want fill the last blank with only even digit. How many even digits are there with us? 2, 4, 8. 3 are there. By using any one of the 3, I can fill this. That's why I can fill this box in 3 ways. Now next I want to fill these 2 boxes. With us, how many actually from 5 elements, any one of them is filled up here. So we have with 4. 4 and 2 blocks. 4p 2 ways I can fill. So these 2 blocks I can fill into 4p 2 ways. After completion of this operation, you can start second one, or first completion of this one, you can start that one. That's why one operation depend on another operation. We need to use concept of product rule. So what I can say answer is 4p2 into 3. That is 4p2 value. 4 into 3, 12. 12 3s are 36. Therefore 36 3-digited numbers which are divisible by 2. One thing. Next, number of 3-digit numbers which are divisible by 4. We need to use the definition of division rule of 4 nana. For example, A, B, C, D is a 4-digit number. When this is said to be divisible by 4 means the 2-digit number formed with the last 2 digits is divisible by 4, the total number is divisible by 4. So, what is the problem here nana? Actually, you want a 3-digit number. In these 3-digit number, the number formed by the last 2 digits divisible by 4. Then only the total number is divisible by 4. Such a way that we want to find last 2 digits first. Possible last 2 digits I will write. Possible last 2 digits. I will write one by one. 24 is possible because divisible by 28 possible. With 2, starting with 2, these 2 only. Next with starting 4, 42 won't divide, 44 will, but repetition won't allow here, 48 I can write. Okay students, with 4 completed, next now I want to start with 7, 72. 72 is divisible by 4 only, with 72 one thing, with 7, 74 won't divide, 77, okay, no. 78 means 38, okay, won't divide, okay, with 72 only. With 8 nana, 82 won't divide, 84, okay, 84 will divide. With 84, 87, okay. Next with 9, 92 by 4 2s are 92 will divide, okay, 92. Next 94 won't divide, 98, okay. So these are the possible last 2 digits. Okay, so now I want to write the answer for this. 3-digit numbers end with 24. What is the meaning of that? Here 2, 4, just to fill this manner. Actually 5 digits are there. Among 5, 2 are already used up. You are remaining 3. 3 should fill with 1 blank. 3p1 ways you can fill. Or I can write 3p1. That is equal to 3. So next 3-digit numbers end with what? I will show. End with 28. Equal to another 3p1. End with 48. The same argument, another 3p1. End with 72, another 3p1. End with 84, 92, another 3p1, another 3p1. Now I am final. Therefore, total number of the total number of 3-digit numbers which are divisible by 4. 3p1 plus 3, here 1 3 is there, 1, 2, 3, 4, 5, 6. So 6 times of 3p1. 6 times of 3, 18. Among the 60, 18 are divisible by 4. Okay, I hope you people understood this. Students, next very important model, difficult model. Important I will write, IMP model. Find the number of 4-digit numbers that can be formed by using digits 2, 4, 7, 8, 9, 0. 0 is involved. That is very difficult. Among how many of them are divisible by 2 and divisible by 4? As usual. First of all, I want to find 4-digit number of 4-digit numbers. Number of, oh shit. Okay, students. Number of four-digit numbers. That can be formed. Directly I want to write answer, but explanation here, Nana. 4 digit numbers means just you want to fill into 4 blanks. How many digits? 1, 2, 3, 4, 5, 6, 4 blanks, 6p4 ways you can fill. 6p4. Listen, student. 6p4 you can fill. So one of the number is 2, 4, 7, 8 among 64. One of the number is 4, 7, 2, 0. But important thing is one of the number is maybe this also 2, 4, 7, 8 also. But this is not 3 digit number. See, this is not 4 digit number, this is 3 digit number. But you want 4 digit number. What you did, Nana, just these 6 elements are filled into 4 blanks. You get 64 4 digit numbers, but all are not treated as 4 digit numbers because one of such some numbers will be like this 0, 4, 7, 8. This is 3 digit number, not 4 digit number. So now what should do, Nana? We want to remove such numbers from 6p4. Such numbers means the number started with 0. Among 64, 4 digit number, some are started with 0. Those numbers should be removed. How to remove? I will show you. I want to find 4 digit number starting with 0. Another words I can say that I want to find the 4 digit number starting with 0. They are not actually called 4 digit number, just like that. So I want to find the 4 digit number starting with 0. So 0 is fixed here. 0 is fixed. Left with us 1, 2, 3, 4, 5 elements are there. We want to fill into 3 blanks. How many ways you can fill? 5p3 ways you can fill. What is the meaning of this? So 5p3 4 digit numbers which are starting with 0. These 5p3 numbers not treated as 4 digit numbers. That's why these 5p3 numbers should be removed from 6p4. So actual 4 digit numbers are 6p4 minus 5p3. I hope you people understood the concept. Okay, in 6p4 some numbers will be like this, Nana. Those are not treated as 4 digit number. That's why first of all among that I want to identify how many of them are started with 0. 0 taken is leading position. 0 fixed here. 3 blanks. Yeah, 5 digits. 5p3 ways can fill. 5p3 ways can fill. So 5p3 4 digit number starting with 0. So 5p4 minus 5p3. Okay. So what is the value of this? That's not big problem. I can write the 6 into 5p3. Important note. NPR equal to n into n minus PR minus 1. Very, very important. That is not big problem to prove this. This is not big problem to prove this. NPR equal n into n minus 1 PR minus 1. By using the definition you can write. Okay, students. That's why directly 6p4 can be written as 6 into 5p3. 6x minus x, 5x, 5x. 5 into 5p3 I can write now. So that is what? 5 into 5p3. 5 into 4 into 3. So 2060. What is that? 300. There are 300 4 digit numbers you can write by using the digits 2, 4, 7, 8, 9, 0. So you don't know that formula, no problem. Directly find 6p4 value, 6 into 5 into 4 into 3 minus 5 into 4 into 3. Meaning, what is 5 into 4 into 3? You can take common. 5 into 4 into 3 taken common, we will get 6 minus 1, 5. 5 into 4 into 3 is 20, 60, 60, 5 are, so 300. Anyway, we will get 300. So first answer completed. Yeah, next, which are divisible by 2 means they should end with even digits. Okay. Second, first part actually that is second part. The number of two digit numbers. Sorry, number of even 3 digit numbers. Number of even 4 digit numbers. Okay, is equal to, later I will write. I will explain a concept important. So this Box should filled with either 2 or 4 or 8 or 0 only. Filled with 0. How many 4-digit numbers you can create so that they are end with 0? Actually, we got 300, no? Among 300, some are end with 0. We want to identify how many of them end with 0. Those are divisible by 2 only. How many of them end with 0? 0 should be taken its place. Remaining how many with us? 1, 2, 3, 4, 5. So 3 blanks, 5. 5p3 ways you can fill. 5p3 ways you can fill. So there are 5p3 4-digit numbers ending with 0. There are 5p3 4-digit numbers. They are all are divisible by 2. One thing. 5p3 plus something. Next, students, important. Sorry, I forgot. No need to erase that. Okay, 1 minute. So I want to erase this. Here some students will make mistake. What is that mistake? I will explain. Next, what happened? The number of 4-digit number end with 2. 2 should be taken its fixed place. So 2 gone. Remaining 5 are there. Blanks 3, 5p3. So what they will say? There are 5p3 4-digit numbers ending with 2. Okay. So what are the? I will write some of them. I will write 4, 7, 8, 2. Okay, Ranana. 4, 7, okay, 9, 2. Some numbers are like this also. 4, 7, 8, 2 also. Among these 5p3. They will start with 0 also, no? So those are not treated as 4-digit numbers. Again, what is the meaning of that? From this 5p3, you want to remove the digits starting with 0. How many of them? Ending with 2 and starting with 0. Those should subtract from 5p3. Okay, Nana? Observe here. So some numbers will start ending with 0 and starting with 0. Those numbers should be removed. 2 places are filled with 2 elements. The remaining how many are there with us? 1 to 4, 2 blank. 4p2 ways you can fill. 4, 7, 8, 9 can be filled into 2 blank. 4p2. What is the meaning of that? There are 4p2 4-digit numbers. They are ending with 2 and starting with 0. Those are not treated as 4-digit number. Those should be subtracted from 5p3. That's what is the meaning. 5p3 minus 4p2 4-digit numbers are exist which are divisible by 2. I hope you people understood. Okay, next 5p3 plus 5p3 minus 4p2. Next, end with 4 with same argument. End with 4, 5p3 minus also some will start with 0. Those should subtract 5p3 minus 4p2. 5p3 minus 4p2. And with 8 also 5p3 minus 4p2. The required number of 4-digit number which are divisible by 2 means 5p3 plus 5p3 plus 5p3 plus 5p3 minus of 4p2 plus 4p2 plus 4p2. I hope you people understood. And now I want to write answer directly. How I can in detailed also I can write. Okay. Now explain. No, directly I want to write 5p3 plus 5p3 minus 4p2 plus 5p3 minus 4p2 plus 5p3 minus 4p2. This is ending with 0, ending with 2, ending with 4, ending with 8. Okay. So that is 1, 2, 3, 4. 4 times of 5p3 minus 3 times of 4p2. Simplify what I will get. Those many numbers are divisible by 2. Okay, this is one task. Next, divisible by 4. Second part. The 4-digit numbers. Which are divisible by 4. First, we want use the divisible rule of 4. So we want to make 2, 4, 7, 8, 9, 0. So you want to find 2-digit numbers which are divisible by 4 first of all. 24, okay. 27, 28, okay. 29, no. 20, okay. Okay. Next 42 won't be. 48, okay. 49, 40, okay. With 4 completed. 72, okay. 74, okay. No. 77, no. 79, no. 70, no. 80. 82, no. 84, okay. 87, no. 88, no. 80, okay. Okay, students. Next, with the 8 complete, 9 with 9. 92, 92, okay. 94, no. 98, 98, no. 90 also, no. Okay, completed. So what happened? Now we want to find 4-digit number. They are end with 24, end with 28, end with 20, end with 48, like that. Okay, so interesting step. I want to write. Students, listen. Yeah, first one. The 4-digit numbers end with 24 or 24, I can say. Directly I want to write answer, but explanation is, I want to give explanation here, students. 24. Total how many? 1, 2, 3, 4, 6. 2 digits taken their places. 2 blanks for 4p2. But again here sometimes we will get difficulty. Among these 4p2, some may be start with 0 and end with 24 also. Those should subtract. Among there are 4p2 numbers which are end with 24, okay. Which are end with 24, okay. But among these 4p2, some will start with 0 also. Those should subtract. Those are not treated as 4-digit numbers, no. Minus, minus. How many are starting with 0, ending with 24? So 3 digits completed, remaining 3 digits, only 1 blank, 3p1. So 4p2 minus 3p1, 4-digit numbers ending with 24. 4p2 minus 3p1. I hope you people understood now. Okay. With 28 also same, with the same reason, with 28 also. Do symbols I will write. With 28 equal to 4p2 minus 3p1. End with 20. 20 is different now. Again, 20 is different. 20 is different. 2 0 means 0 here only, no problem with that. So directly I can say 4p2 only, not 4p2 minus 3p1. Directly I can say 4p2. Understood? With 24p2, with 44p2, with 84p2, with 48 again 4p2 minus 3p1, like that. Okay? Okay, end with 48. Directly I want to write answer here, that is 4p2 minus 3p1. End with 40, only 4p2. End with 72, Nana, that is what? 4p2 minus 3p1. 84, 4p2 minus 3p1. End with 80. 80. That is 4p2 only. No need to subtract. So final answer I wanted. Total number of required numbers. Required numbers. Required numbers means number, not required numbers means number how many? Equal to here 1, 2, 3, 4, 5, 6, 7, 8. 8 times of 4p2 minus 1, 2, 3, 4, 5. 5 times of 3p1. Actually, we need to simplify. Students, I want to simplify. 4p2, 4 into 3 only, no? I can definition. 12, 8 times of 12. 5 into 3. 12 8s are 96, minus 15, 1, 81. Therefore, there are 81 4-digit numbers which are divisible by 4. This interesting problem. Please cross check my calculation. Sometimes I will make mistakes. No? Okay. Okay, students, another situation in linear permutations only. Linear permutation when repetition is allowed. So we actually explained two things, two situations. In linear permutation, repetition won't allowed. In linear permutation, repetition will allowed. So through example, I will explain the meaning of this. For example, by using the digits 1, 2, 3, 4, how many 2-digit numbers you can write means I can say that 4p2 2-digit numbers you can write. 4p2 means 12 2-digit numbers you can write, which is same as filling these 4 digits into 2 blanks. 4p2 ways you can fill. Okay, or by using fundamental theorem of counting, I can say that first blank I can fill 4 ways, second blank I can fill into 3 ways, because here repetition won't allowed means, for example, first blank is filled with 2, the same 2 I can't use to fill the first blank. That's why second blank, the possible number to fill the second blank is 3 only. That's why what I can say, second operation I can perform into 3 ways, first operation 4 ways, product rule I can say 3 into 4, that is equal 12 ways I can fill these 4 elements to 2 blanks. What is the meaning of here? Repetition not allowed. If repetition is allowed, what is the meaning of repetition allowed? Any number can use any number of time. First of all, sorry, 2-digit number only, no, you want? Okay, I will, okay, 2-digit number only you want. First of all, I want to fill the first blank. Using these 4, any one of the 4 I can fill in 4 ways. Now I want to fill the second blank. For example, first blank is filled with 2. Again, same 2 I can use to fill the first blank, because repetition is allowed. Means these objects can choose any number of time. That's why the second blank also I can fill into 4 ways. So these 2 successively I can fill into 4 ways, that is called 4 2 square ways, that is called 16. There are 16 2-digit numbers exist when repetition is allowed. Okay, 4 after that 11, 12, 33, 44 should add. Already got 12, no? 12 plus 4, totally 16. This is the meaning of repetition is allowed. One thing, students, listen. So, in linear permutations, in formula of NPR, n factorial by n minus r factorial. So, what is the meaning of this? Here repetition won't allowed. N distinct objects are given. From n distinct objects are chosen. These are filled into r blanks. When repetition is not allowed, how many ways you can fill means NPR ways you can fill. How you got? First blank you can fill into n ways, second blank n minus 1 ways, third blank n minus 2 ways, and so on. If repetition is allowed, first blank you can fill into n ways, second blank also you can fill into n ways. Same object can use here to fill. That's why second blank also I can fill into n ways, third blank n ways, fourth blank n ways, so on. Rth blank also n ways. So n into n into n into r times. That's why n power r. That's why here n power r. When you will use this formula, NPR equal n power r. When repetition of the object is allowed, means in given object you can use any object any number of time. Okay. The permutations of object when repetition is allowed will be equal to n power r. The meaning of that is any object use any number of time. Observe, students, here n objects are there with us, all are different. We want to fill these n object into r blanks. R minus 1th blank, rth blank, first blank, second blank, third blank. First blank I can fill by using any one of these n ways I can fill first blank. Second blank also n ways only. For example, I filled this blank with this. Again I can use that. Any object use any number of time. That is second blank also I can fill into n ways only. Third blank n ways only. So on. Rth blank also n ways only. From fundamental theorem of counting, total operation you can perform into n into n into n into n into ways. How many n's repeatedly multiplied? R times. That's why n power r times you can fill means there are n power r such linear permutations. Okay, students. This is also one of the important formula for us. Okay. Therefore, NPR equal to n factorial by n minus r factorial. Repetition not allowed here. Repetition of the object is not allowed. Not allowed. same NPR equal to n power r when repetition allowed is allowed. Sometimes they will ask, find the number, very important, listen students, find the number of permutations, find the number of permutation means a linear permutation in this section, find the number of linear permutations that have at least one repetition, no repetition here, no repetition, here repetition, no repetition. What is the question? Find the number of linear permutations that have at least one repetition. I will write number of linear permutations that have at least one repetition. At least one repetition. So, listen students, here no repetition. N power r minus this gives n power r minus what is that? I can say NPR. NPR means actually generally NPR means you will use this. You are not using NPR for n power r. Just when repetition allows, you can say NPR. So n power r minus NPR I can write. What is the meaning of that? N power r minus n factorial by n minus r factorial. When we will use formula, sometimes you need a number of linear permutations having at least one repetition. The number of linear permutations that have at least one repetition or that having at least one repetition is equal to n power r minus NPR nana. So, or n power r minus n factorial by n minus r factorial. This is also very important note. Yeah, example problem. Actually, linear permutation concept completed. Now we want to solve problems based on linear permutations. So clearly I explained that Venn diagram, permutations and combinations. In permutations, linear permutations, circular permutations. In linear permutation, permutation without repetition, permutation with repetition. So for this formula I derived, that is n factorial by n minus r factorial. So this I derived from n power r. So here also in linear also things all the objects are different. Here also all the objects are different. So special case is some things are alike, just like A, B, C, D, A like that. That is special case, I will explain later. Okay. Simple problem. 18 PR minus 1 is to 17 PR minus 1 equal to 9 by 7, 9:7, I will write like that, 9:7, then find the value of R. Easy problem only, just you need to use formula to solve this problem. 18 factorial by 18 minus of R minus 1 factorial. Division, no, I will write reverse. That is 17 minus of r minus 1 factorial by 17 factorial equal to 9 by 7. I hope you people understood what I did here. Direct step. 18 factorial means 18 into 17 factorial I can write. Why this is 18 minus r plus 1 factorial, that is 19 minus r factorial. 19 minus r factorial into here 17 minus r plus 1 factorial, that is 18 minus r factorial, that one 18 minus r factorial, 18 minus r factorial, okay, by 17 factorial. This 17 factorial, this 17 factorial cancel, equal to 9 by 7. Okay students, listen now. Again 18 by some k factorial, assume the k factorial, this one. K factorial can be written as k into k minus 1 factorial. What is that? 19 minus r into 19 minus r minus 1 factorial. What is that, Nana? 19 minus 1, 18 minus r factorial, you know, that's why 19 minus r into 18 minus r factorial. Top 18 minus r factorial by 1 equal to 9 by 7. What happened, Nana? This also get cancelled. What will have? I will write 18 by 19 minus r equal to 9 by 7. Just we need to solve. Yeah, 18 7s are 56, 7 1s are 7, 126. 99s are 81, 171, 171 minus 9r. Or 9r equal to 171 minus 126. 171 minus 126. 4, 5, here 6, 4, 45. 9r equal to 45. R equal to what, Nana? 5. Therefore, the required R value equal to 5. In this way, I can complete this problem. Next, 6 NP3 equal to 6840. Then find n value. Interesting problem. Using formula, okay, but it become difficult. Actually, n factorial by n minus 3 factorial equal to 6848. So here very difficult to solve the problem. So by using logic, you want to complete the problem, Nana. You want to use the logic, you want to complete the problem. What is the meaning of actually 6p3 means? What is the meaning of that? 6 into 5 into 4. 6 is reduced, you know, 6, 5, 4, 3 times, like that. That concept should use here now. What is the meaning of this? NP3 means what I can write? N into n minus 1 into n minus 2. Okay, equal to 6840. Such n value you want to find. So multiplying these three, you get a third degree equation n. That also become difficult. Here n is natural number, you know, you can compare a into b equal to, for example, 12. What I can say? A into b equal to 3 into 4, a equal to 3, b equal to 4, one possibility, or b equal to 3, a equal to 4, another possibility, or 1 into 12, a equal to 1, b equal to 12, or b equal to a equal to 12, b equal to 1, like that several possibilities. 6 2s are a equal to 6, b equal to 2, or a equal to 2, b equal to 6. So if this is these two are natural numbers, you can compare and you can find the values of a and b. That is not big problem. Here also. So no need to multiply these three brackets. If you multiply these brackets, you get a third degree expression equating to 6840. You get third degree equation. Solving that become very difficult. So logically, you want to solve the problem means you want to write this into product of three consecutive factors. Okay, that is the logic. Okay, I will write 684 into 10. 4 into 4 ones are 4, 7, 1 into 10. 7, 8, 9, it divisible by 9. 4 into 9, ones are 9. 9 ones are 9 means what is the 181 9s are into 10. What is showing that? 19 is one of the factor of this. 19 means another factor may be 20 or backside 18. I think 20 will get. 20 I will write 20. 19 completed. This 10 with 2 completed. 9 2s are 18. What is the meaning of that? That number can be written as 18 into 19 into 20, or in order. In order, what I can write? In order 20 into 19 into 18. What is the meaning of that? This 20p3. What is the value of n, Nana? 20. Okay, in this way you can complete this problem.